All right, class, now that we've gone over how to calculate quartiles for a data set, I want to talk about how we're going to be using those quartiles. And the main way we use quartiles is in a 5-number summary, okay? A 5-number summary for a data set can really show you its distribution. So those 5 numbers we're going to be looking at are the minimum, Q1, which marks the 25th percentile, our median, which marks the 50th percentile, and our upper quartile, which marks the 75th percentile, and then our maximum value. That's our highest value, okay? This is a 5-number summary. It can tell you a lot about a data set. So for example, here are the 5-number summaries of 2 banks, Big Bank and Best Bank. Very creative, I know. So we're going to use these 5-number summaries and we're going to represent them graphically, right? Because this list of numbers doesn't tell us a whole lot. It doesn't show us a lot about our data set. But it will if we represent them as a box plot. So a box plot is a graph that displays data using our 5-number summary. Now, one thing I didn't mention is that down here there is a number line. Okay, and we graph them. They're also sometimes called box and whisker plots. So we have our median in the middle, our Q1 and our Q3, that creates our box, and then we attach our minimum and our maximum with whiskers. The difference between Q3 and Q1, that's called our interquartile range. It's the range between quartiles. So I'm going to go into a little bit more detail of how to make a box plot. So here it is broken down a little bit more, right? The 3 quartiles divide the box plot into 4 sections. Each contains about 25% of the data. It defines what our minimum and maximum is and how to calculate the interquartile range, which you'll see abbreviated as IQR. So why don't we go ahead and make a couple of box plots. So when drawing a box plot, the first thing you need to do is draw a number line that spans all the values in the data set. The next thing we need to do is enclose the values from the lower quartile to Q1 to the upper quartile in a box and draw a line through the box at the median. And then we have to add whiskers. So that's going to extend to our minimum value and our maximum value. So let's go ahead and make a couple box plots for Big Bank and Best Bank. So let's construct a box plot for Big Bank and Best Bank. And then I want you to tell me which bank you would like to go to and why, or think about it. So let's go ahead and make the box plot for Big Bank. My minimum value is 4.1, my maximum value is 11, so I need to make sure that my number line includes all those values. I don't have to start at 0. I'm going to start at 4. 4, 5, 6, 7, 8, 9, 10, 11. And that looks like a pretty even number line, if I do say so myself. So the first thing I want to do is I want to graph my lower quartile. That's going to be 5.6. That'd be right about here. I have to graph my upper quartile. That's an 8.5. I'm going to enclose those in a box. I'm going to plot my median, which is 7.2. I guess that's right about here. I plot my minimum, which is 4.1, and my high, which is 11, and I attach those with whiskers. Now remember that these are the waiting times for banks. So that means the minimum someone had to wait was 4.1, but the maximum someone had to wait was 11 minutes, right? The median, so the middle range, is 7.2 minutes. So that's for Big Bank. Now let's look at Best Bank. Should I change color? I guess I should. Best Bank. So what's interesting about Best Bank is my lowest is a 6.6 and my high is a 7.8. I'm actually going to use the same number line as Big Bank so we can compare the two. So I had a 4, 5, 6, 7, 8, 9, 10, 11. So my lower quartile is 6.7. I guess that'd be right about here. My upper quartile is 7.7. I guess that'd be right about here. I'm going to plot that. I'm going to draw my median, which is 7.2. My minimum, which is 6.6. Oh, it's so tiny. And my maximum, which is 7.8. Again, so tiny. So the question is, which bank would you want to go to? Okay, so with big bank, you could wait less time, or you could wait even more time than best bank, right? Best bank, at least all their wait times are really close together. There's not as much variation in the wait times. So it'd be up to you. We'll learn more about this when we go into discussions about variation and range. Range is the set of values a data set can take on. So big bank, because it has a bigger graph, has a wider range, where best bank has a smaller range, right? It's just between like 6.5 and almost 8.